Welcome to the working of an aluminium recycling plant. First, let us briefly go over the essentials of the aluminium recycling process. In the recycling process, aluminium in the form of sheets, automobile components, engine blocks, window cuttings, utensils, used beverage cans, etc. is considered as scrap aluminium. The aluminium castings and engine blocks of automobiles are shredded, while the window cuttings, utensils and used beverage cans are baled. The baled products are then charged into the furnace in predetermined ratios as is suitable for the required finished goods composition. This is in turn cast and cooled to produce ingots of aluminium. This process requires the temperature to be maintained between 750 degrees Celsius and 800 degrees Celsius. Now, let us go over the process in detail. Scrap aluminium is received at the plant in trucks and containers after being weighed properly. The scrap is then manually segregated as castings and extruded parts. The castings normally comprise of automobile parts, engine blocks, etc. and need to be shredded before melting. The extruded parts come from aluminium sheets, used beverage cans, utensils, window cuttings, etc. and are baled. The castings are charged manually into the in-feed conveyor of the shredder. The in-feed conveyor is a flat surface that carries these castings to a height of about 6 meters. From here, the castings are charged to the rotor shredding arrangement in order to be shred. After the shredding process, the products are reduced to approximately the size of your fist. These shredded products fall on the outfeed conveyor belt by gravity. Plastic and other non-metallic pieces are manually sorted out by personnel. The remaining material goes onto a magnetic separator, which picks away the iron pieces. The iron attachments in the aluminium are separated with the help of nibblers. The output, referred to as processed scrap, is stored in designated bins to produce different alloy ingots. There may be 2 or more kinds of processed scraps depending on the kind of raw scrap fed initially. All the utensils, window cuttings and used beverage cans will be charged into the baler manually. A 3-dimensional baling press compresses the scrap from 3 sides to make a bale measuring 14 inches by 14 inches by 10 inches. Each compressed bale weighs about 35 to 40 kilograms. The bales, referred to as processed scrap, are transferred to the designated storage areas by forklifts, again depending on the type of scrap. We now come to the final step of the recycling process, which comprises of the melting and ingot casting of the processed scrap. A reverberatory furnace is employed for this procedure. The burners are ignited using a mixture of furnace oil and air to produce flames in the furnace. As per the finished alloy requirement, different combinations of scrap are charged into the furnace. Forklifts are used to carry the processed scrap to the charging door of the furnace. As the burners produce heat, it is absorbed by the hearth and refractories in the furnace, which in turn melts the scrap at 700 degrees Celsius. To make the process environmentally safe, an elaborate air pollution control unit or APC is employed. The APC consists of a dust collector, a spark arrestor, a bag house, a cyclone and a chimney. The smoke from the furnace first passes through the dust collector where the dust particles separate and accumulate. The spark arrestor ensures no sparks escape and avoids any unforeseen damages to the bags in the bag house. The smoke is then further cleansed when it goes through the cyclone and the bag house. The fuel gases emitted from the stack conform to the environmental norms. Once the total charge has melted, it is oxidized to remove impurities and is then reduced. Based on the requirement of the finished good composition, alloying elements are added. The molten metal is now ready for ingot casting. The molten metal is poured into the ingot molds through launders by tilting the furnace hydraulically. The cast ingots are cooled by a spray water system on all sides. After cooling, the ingots from the conveyor belt will fall at the trailing end and are collected. These ingots are then arranged into stacks, which are loaded onto forklifts. These are then made into bundles, strapped properly, and then stored. Welcome to our battery recycling plant. First, let us briefly go over the essentials of the battery recycling process. The battery recycling process comprises of two main processes: recycling of the plastic and recycling of the lead. To begin the recycling process, the batteries pass through the battery cutting unit. Here, the battery cutting machine cuts through the battery, separating the top of the battery from the container. The plastic container and the lead contained within the battery are processed separately. Each battery consists of several lead plates, terminals, separators, etc. The batteries are placed vertically on the conveyor belt to be transferred to the battery cutting unit. The top cutting operation is carried out by two high-speed rotary cutters. After the batteries are cut, the lead is extracted from the plastic shells. The shells are then sent to the plastic recycling section and the mixed lead to the lead section. The terminals are hand-picked and kept separately. The lead plates and lead powder mixture pass through a rotary cum vibratory sieve which separates the lead powder from the lead plates. At the end of this process, only the plastic grid will be left behind. This will be sent to the plastic line to be processed along with the plastic container. The lead powder is charged into the reverberatory furnace as alternate layers along with charcoal. Charcoal acts as a fuel as well as a reducing agent. After reduction, the liquid metal and slag is tapped through the tapping hole. The slag is skimmed off, removed, and the liquid lead is cast into molds. The slag obtained from the reverberatory furnace is further treated in the rotary furnace to recover the residual lead. Once melted, liquid lead is poured into cast iron molds. The refining process is carried out with the help of chemicals. The purified lead is cast through a pouring valve. In the event of making the alloy, the necessary additives are added to the molten lead in the alloying kettle, while the terminals and lead plates are charged into the melting pots. The molten metal is poured into the ingot molds to be cast. These ingots are then arranged into stacks, which are loaded onto forklifts, made into bundles, strapped, and then stored. To make the process environmentally safe, an elaborate air pollution control unit or APC is employed. The battery recycling plant consists of 3 APCs, each for the reverberatory furnace, rotary furnace, and the alloying and refining kettles. Each APC consists of a dust collector, a spark arrestor, a cyclone, a baghouse, and a chimney. The smoke from the furnace first passes through the dust collector, where the dust particles separate and accumulate. The spark arrestor ensures no sparks escape and avoids any unforeseen damages to the bags in the baghouse. The smoke is then further cleansed when it goes through the cyclone and the baghouse. The fuel gases finally emitted from the stack are cleansed enough to conform to environmental norms. The plastic battery containers or shells are placed on a conveyor belt which transfers the shells to the grinder. Here, the shells are ground into small pieces called chips. The plastic chips are rinsed in a tank twice or thrice to free it of any residual lead content. The chips are then sent for a hot wash via a spiral conveyor. Hot water with caustic soda and acids cleans the chips and ensures that they are free from battery content and particles. After the hot wash, the chips are transferred to a high-speed scrubber with the help of a spiral conveyor. Here, they are cleaned again to remove the remnants of the caustic soda and acids. From the scrubber, the chips are transferred to a centrifugal dewatering system to remove any moisture, and then transferred to a drum mixer where reagents like whiteners, softening agents and dispersion agents are added and mixed with the chips. The chips are now moved to an extruder where plastic extrusion takes place. The extruded plastic pieces are water quenched and cooled, and then sent through a gale dryer for dewatering and drying. Finally, the extruded plastic is passed through a granulator to be made into tiny granules. The granules are then weighed, packed and sealed as per the requirements.